So this is going to be the second video where I remake an old one. This one is going to be about charge, formal charge, and oxidation state, because I wanted to add some dialogue on that subject. So first off, what is charge? Charge is the property that dictates how things interact via the electromagnetic force. So it's basically the mass of electromagnetism. In fact, the entirety of chemistry exists because of charge. In chemistry, charge can range from partial to almost completely ionic, but it's never fully ionic, except for in the case of plasma. Partial charges can also be found in quarks, but we're not discussing that because this is not a quantum physics lecture. Formal charge is an imaginary number that describes the charge of a molecule, assuming that all electrons are shared equally, excluding ionic bonds, which they obviously aren't. Also, it assumes that the structure of the molecule is exactly how we expect, which often isn't the case. It can be calculated by subtracting the number of non-bonding electrons and the number of bonds attached to an atom from the number of valence electrons on a neutral one of those atoms. Oxidation state is the imaginary charge of an atom, assuming all electrons on a given bond are given to the most electronegative atom. It can be calculated by the formula OS equals O minus R plus F, where O is the number of bonds to a more electronegative atom, R is the number of bonds to a less electronegative atom, and F is the formal charge. Now, this only works if the formal charge is correct, and oftentimes the formal charge will be wrong, even though it's an imaginary number and we can technically make up whatever we want. It can still just be arbitrarily wrong, even as a formal charge. The term oxidation refers to an increase in oxidation state, and reduction is the decrease in oxidation state. Now, technically, oxidation state is a made-up number, so it doesn't really exist, and technically everything is a redox reaction because it involves some shift in electrons between atoms. So, yeah, but usually when people say reduction or oxidation, they're referring to increase or decrease in oxidation state.